Hey everyone, this is Jason from organicchemistoncall.com again. So we're going to continue along the naming of alkenes. So in this point we're going to be talking about the EZ. Last time we talked about the cis-trans relationship, but we'll notice with these compounds that we can't use that. So we're going to be using the EZ nomenclature, where E is the opposite side, kind of like trans, and Z is the same side. We can think of cis. One way to remember this is Z, you can think of same side. Now, as I was saying, that we can't use our cis-trans relationship here because, as we saw in the other examples, when we think about cis-trans, we think about the hydrogens. We're going to have one hydrogen on each carbon, and whether they're side by side or across from each other, that's going to dictate whether it's cis or trans. So in this case, if we look at this example specifically, we'll notice, well, are these the groups that we want to think about as a relationship, or is it these two groups? So what we're going to do is we're going to split our double bond in half. We're going to think about a left side and a right-hand side. And when we do that, what we're going to do is we're going to look at the atoms that are directly attached off of the carbon-carbon double bond. And we're going to look at the molecular weight. So in this case, we've got a carbon that's directly attached, which has a molecular weight of 12. And we have a hydrogen that has a molecular weight of 1. So what we do is we assign the highest molecular weight a priority of 1, and we assign the lower one a priority of 2. So in this case, our carbon or our CH3 group is going to be 1, and our hydrogen is going to be 2. Now we're going to switch over to the right-hand side, and we'll notice here that the atoms directly attached to the carbon-carbon double bond are carbons. So those have the same molecular weight of 12, so that's not going to give us a differentiation. So what we're going to have to now do is, what we start to do is move off of that atom and look at all the atoms directly attached to that and see if we can find some sort of difference. So if we hone in here, we're going to notice that we've got hydrogens and an OH. So if we focus on the hydrogens themselves, we can cancel 2 of them on the top and 2 on the bottom, and that leaves us with the bottom carbon with 1 hydrogen and the top carbon with an OH. So you can already see here the distinction. So at the top carbon, we've got an oxygen coming off of that carbon, which has a molecular weight of 16. And the bottom one, we have another hydrogen, which is a molecular weight of 1. So in that respect, our 16, our oxygen is going to have the highest molecular weight, so that's a 1. Our hydrogen is going to have a lower molecular weight, so that's assigned a priority of 2. And now we can see that our 1s are on the same side and our 2s are on the same side. So in this case, this is going to be a Z alkene. So the relationship, if we look at this, are those two groups, not the methyl groups. So what I'll do here is I'll leave the other structure up to you and see if you can assign it.